Have you ever wondered how computers store and process information? It all starts with a byte. A byte is like a tiny container that holds digital information. Imagine a light switch that can be either on or off. That's a bit, the smallest unit of data. A byte is a group of 8 bits, like having 8 light switches together. Each byte can represent a letter, a number, or even a symbol. For example, the letter A is represented by the byte 010000001. The number 10 is represented by the byte 00001010. By combining bytes, computers can store and process all sorts of data, from simple text documents to complex video games. Bytes are the fundamental building blocks of digital information. Everything you see and do on a computer, from browsing the internet to watching videos, is ultimately stored and processed as bytes. Understanding bytes is essential for understanding how computers work. Just like we use letters to form words and sentences, computers use bytes to represent different types of data. Characters, such as letters, numbers, and symbols, are each assigned a unique byte code. This allows computers to store and display text. Numbers are also represented using bytes. Each digit in a number is assigned a specific byte value. This enables computers to perform mathematical operations on numerical data. Instructions, which tell the computer what to do, are also encoded in bytes. Each instruction has a specific byte sequence that the computer understands and executes. We often work with large amounts of data, so we need bigger units to measure them. That's where kilobytes, megabytes, gigabytes, and terabytes come in. Think of it like this. If a byte is a single letter, then a kilobyte is like a paragraph, a megabyte is like a page, a gigabyte is like a book, and a terabyte is like an entire library. A kilobyte is 1024 bytes. A megabyte is 1024 kilobytes. A gigabyte is 1024 megabytes. And a terabyte is a whopping 1024 gigabytes. As technology advances, we're using even larger units like petabytes and exabytes to measure the massive amounts of data being generated. These larger units help us make sense of the vast amounts of data we store and process every day. From photos and videos to music and documents, our digital lives are measured in bytes. Now that we know how data is measured, let's talk about where it's stored. There are different types of computer memory and storage devices that hold our precious bytes. RAM, or random access memory, is like a computer's short-term memory. It stores data that the computer is actively using. RAM is very fast, but it's also volatile, meaning that it loses its contents when the power is turned off. ROM, or read-only memory, is like a computer's long-term memory. It stores permanent instructions that the computer needs to boot up. ROM is non-volatile, meaning that it retains its contents even when the power is off. HDDs, or hard disk drives, are like filing cabinets for our data. They use magnetic disks to store large amounts of data. HDDs are slower than RAM, but they can store much more information. SSDs, or solid-state drives, are like flash drives, but much faster and more durable. They store data on electronic chips and are becoming increasingly popular due to their speed and reliability. Understanding the different types of data storage helps us choose the right storage solutions for our needs. Whether we need fast access for everyday tasks or long-term storage for our files, there's a storage device out there that's perfect for the job. So